Here's a really tricky problem. Find the value of a such that the square root of x to the 4 times the cube root of x cubed times the fourth root of x squared is equal to x to the a. So we need to do a lot of simplification of the left-hand side here. And let's start from the inside out here. So we've got the fourth root of x squared. That would be x squared to the 1/4. So by the rules of indices, that's x to the 2 times 1/4, which is x to the half. You might just be able to say the fourth root of x squared is the square root of x, which is x to the half, more quickly as well. So if I times that then by x cubed to get x cubed times the fourth root of x squared, that's x cubed times x to the 1/2. The rules of indices now tell us add 3.5 to get 3.5, and so that's the same as 7/2. Easier to work with top-heavy fractions in this sort of question. And then I want to take the cube root of this, so actually let's just put a cube root around our answer here. Okay, and then that's x to the 7/2 to the power of 1/3. Then I multiply those powers again, and I get x to the 7/6. So we're almost done here. We just need to now multiply this by x to the 4 and take the square root, right? So x to the 4 times all of this stuff that we've just worked out is going to be x to the 4 times x to the 7/6. And again, I'm going to add the powers there. So x to the 4 would be x to the 24/6 times x to the 7/6. That gives me x to the 31/6. And then I just need to take the square root of all of this. So let's put a big square root over all of this. Okay, well, that's going to be x to the 31/6 to the power of 1/2. And then I just multiply the powers again. 31/6 times 1/2 is x to the 31/12 then. Let's write that to make sure it's really clear that that's a power. And so the value of a here is going to be 31/12.